on how to operate the organometallic filament with a 3D printer. The first thing you want to do, I'm using this old laptop here. The first thing you want to do is you load SketchUp right here. You generate your model. So this is the scalpel. Note that it's printed diagonally. That's because otherwise it will not fit into the print bed up here. So this printer is slightly different. That's the next one we made, but the extruder is exactly the same. You generate the model. Once you're happy with the model, you export it as STL. It will ask if you want to export the entire model. You say yes, obviously. And you save it someplace. Next, you load the printer interface. It's called Printerface. The first thing you do is you set the heater to temperature 195, and then you set the bed to as high up as it will go. Now this one goes to about 110. The one you have will go to about 90. It doesn't actually matter. You can type in whatever number you want. Next, you load the filament, and just to make sure that you reach and after you load it, you have to hit extrude a few times. You want to do it slowly. You want to do like 550, so 5 millimeters at 50 millimeters per minute. So you hit extrude, and this is just to make sure that you can see the filament come out of there, because otherwise it will not start printing when it thinks it's starting to print. And you're probably going to have to do it a couple of times. This regrettably wastes a bit of filament, but that's life. You can see it sort of starting to come out there. And when it's done, you want to pull it off. Now this is going to be hot, so don't do this with your hands. You're going to need like a piece of paper or something. Okay, now it's set. So next thing you do is you go to settings. You go to slicing settings. And there's going to be a bunch of presets here that you can use. Now I have a few here. The one you're probably going to have, the default is Solidoodle TC. You want to use the slow setting. If you do not have the slow setting file, I'll send you it. All it changes is in the speed. You can do this manually if you want. You can set it to here. So the bridge feed is 0.5, the bridge flow is 0.5, duty cycle you leave alone, the feed rate is 15, the flow rate is 0.7, the travel feed is 40, and all the other settings you leave alone. Now what this basically do is that it makes the printer slow down to about half of its design speed. You need to do this for this particular kind of filament because it has a higher thermal mass. Otherwise it will clog in here. Now once you're done, you open the file. So in this case we have High-Seas example scalpel. You open the STL file, and in the meantime this should be getting to temperature. That's why I say send it to temperature before you do the slicing. Now what it's doing now is that it's generating a G-code file from the STL file. The STL file is a 3D file. The G-code is a series of instructions for the printer on how to move. You only have to do this once. If you print more than one object per type, you just open the G-code directly. This kind of thing, it takes a little bit of time. So normally you use this time to get the heater to temperature. Clearly, if you're just loading the G-code, you're going to have to wait a bit until the heater goes to temperature. I just figured I'd skip the boring parts. The other thing you have to do is, before all this, you should have trimmed the Z-axis screw, this guy here. And you want to make sure that the extruder is touching the Kapton, but not pushing onto it. You will have to do this by trial and error. It will take a couple of attempts. In the meantime, by the way, you can see that the mount for this laser is slightly different. Your laser is horizontal, mine is vertical. That's really the only difference. We're not using the laser today. Let's just get the printer going for now. And this one also has a liquid printer. This is by request of Dr. Joel. Screensaver tripping. So it's done generating the G code. So you open load file, the G code file, check temperatures, cross your fingers, and hit print. Now the printer will home itself and then start printing, because that's what it's supposed to do. You can see it operate. Now, if you do not get adhesion at this point, that's when you hit stop. You cannot get adhesion at this point, that's the part when you hit stop. However, in this case, we are looking pretty good. Note that this will print a raft. This again wastes a bit of filament, it's optional. I do this simply because I find that for the scalpel at least, it actually makes it easier to file an edge into it later. In fact, with doing this, it squishes the filament a bit so that instead of it being a 0.3 millimeter thick, it's about 0.1. That gives you a much better edge. You don't actually need to sharpen it if you need to. Okay, so this thing is going to slowly print you a knife. Now that's kind of boring to look at, so what we're going to do is we're going to put this thing on a tripod and let it run. And I'm going to edit this so that you get some kind of time lapse. Again, this is kind of the boring part, so we're just gonna sit here until it does things. You can actually see it. Let's move the lights around a bit. The problem is that the caddy for this guy is not very good, is not very small, so it actually doesn't let you see very much. You can see the back part of it. For the record, this is the other printer printing a lot faster because we're using normal filament for that. Alright, that was a mostly successful print. It messed up at the end there, but we got a usable knife out of it. And here it is. It's like it missed the last 3 layers. By the way, whatever happens, just hold down this part and this part with a bit of tape. So, having got as a knife, what we do now is we break off the swerve. This can be done by hand or with another blade, but that kind of runs it into a bit of a chicken and egg problem. This. Now all the swerve can be put back into this machine, which you guys don't have because I just finished building it, and recycled. The recycling rate is about 98%, which is pretty decent. So the next thing we do is that using the provided using the provided sandpaper. So you're going to have to go a bit on edge. It's something you should only have to do once. It will keep it almost as well as metal stuff. And one thing that's interesting is that these diagonal pieces of plastic give you a bit of serration. You can either keep it or you can remove it entirely, and that will give you a different cut. And speaking of cuts, here's a cut of meat, and here's cutting the meat. Just to give an example, this is with more serration. And this is with less serration. You gotta decide just how much you want to use. Again, if this is for a medical simulation, I recommend kind of spending a few minutes doing this. And that's it. Now this is the end of the demo. Now I think we're gonna have some steak.